up a very significant rock, typical of what we have here in the valley of THRU. It's a rock composed of many fragments of many sizes.
Between July 1969 and December 1972, 6 Apollo missions placed 12 American astronauts on the moon. They did not come home empty-handed. They brought with them 842 pounds of lunar samples, rocks, cores, and dust. NASA, the National Aeronautics and Space Administration, presents a special report, Moon Rocks Today, a look at a legacy for tomorrow. Besides the 6 sites on the moon visited by the Americans, samples have been returned from 3 other locations by the Russians' unmanned moon missions.
They've returned about 2/3 of a pound total for these 3 missions, and that a portion of those samples have been exchanged with the United States.
That's Pat Butler, curator of the lunar samples at NASA's Johnson Space Center near Houston, Texas.
This is a time to take stock of what the lunar program is doing and what is going on with the samples and what we have in the way of samples. From our lunar sample curatorial facility here in Houston, we've distributed not only the Apollo samples from the 6 missions, but we've also distributed the portion of the Russian samples that were exchanged to our principal investigators, the scientific laboratories that work in the United States and also throughout the world that have arrangements to study our Apollo samples, have received samples from the Russians. In exchange, we gave the Russians the same amount of sample, about 3 grams, a small fraction of an ounce of samples from each one of our missions. This means that under the present arrangement, if the Russians have another mission to the moon, their last one was in August of 1976, if they return more samples, that the scientists in the United States will be getting another area on the moon, will be sampled and have samples studied by us.
Our present solid sample knowledge of the moon comes from those 9 locations. We asked Mr. Butler what has happened to these 800-some pounds of samples.
We've kept 88% of these, has stayed here in Houston under nitrogen atmosphere, very pure gas, inert, unreactive gas, inside cabinets, glove boxes, and so they haven't been out into the atmosphere or been touched by human hands and have been kept free of any kind of earth materials. And so that 88% is our legacy to future generations of scientists who will need very pure samples and will have to know what exactly came from the moon and be assured that nothing that they find in those samples came from Earth. The remaining 12% of the samples have had various histories. 2% of these samples are in museums on display and have also been circulated as sample collections, representative sample collections first to universities for studies in earth science departments, geology departments, and now we're preparing plastic discs containing 6 samples each, 6 typical lunar samples that are going into the high schools and into the school systems. The scientific laboratories that are studying the samples have 3% of this 800 pounds of samples are currently under active study, and the number of laboratories involved are about 100. 80 of these are in the United States and 20 are in Europe or in Japan and Australia.
In the 9 years of research since the samples have been returned to Earth, 2%, 16 pounds, has been used up.
These would be dissolved in chemical analyses and also burned up in various instruments to study the compositions of the samples. The remainder of the samples are 5% of the samples have been out and been studied and have not been consumed entirely in the study and have been returned to our laboratories here, where we use them to reissue them for scientific study, where the most pristine or the most pure samples are not really required. So we'll keep reusing that 5% of samples to conserve the amount of absolutely pristine and untouched samples for as long as possible, for a long period, for hundreds of years for people to study. Some of the uses of the samples, or the reasons people do research on the samples, are interesting.
A large number of scientists are interested in the moon itself, where it came from, how it was formed, and how it has changed after it was first formed.
It, like the Earth, was formed at approximately the same time the Sun was formed and the rest of the planets in our solar system was formed, and that was 4,600 million years ago approximately. So everything is about the same age, but the moon is a different size from the Earth, and so it had a different subsequent history just because of its difference in size, and it's of interest to see how it evolved and try to get some insight on how the Earth evolved. The first thing that happened is that the surface of the moon probably melted, and then a crust formed on it. The energy just from the collection of particles that formed the moon, the same as happened with the Earth, stored up a lot of heat energy, which caused an early melting on the surfaces of both planets. The moon, however, unlike the Earth, has not had a long, long history of melting and constantly regenerating the crust on its surface, or it has no atmosphere, unlike the Earth, and so there's no weathering of the rocks, and so it's possible to see the early history of the moon, where it'd be much less possible to, or very improbable, that we would find any part of the original crust of the Earth.
Some of the samples returned from the moon are as old as the moon itself. But not all lunar material is unaltered. Meteorite bombardment has had its effect.
The moon is not entirely, was not entirely insulated from any kind of alteration processes once it formed, because it was subject to considerable bombardment of meteorite-like objects. The material that, same sorts of material that form the planets themselves, continued to bombard the moon with decreasing frequency, and of course we have meteorites and continuing to impact on the Earth now. But the early materials were the materials that altered the surface of the moon and gave it its present appearance, a sort of circular crater-like appearance that can be even seen by the naked eye from Earth. Did to a large extent cause alteration to the original crust. So the research that's being done on the moon to look at early crust has to unscramble and subtract out the effects of that early meteorite bombardment. Many of the rocks have been ground up, scrambled up, melted, and reconstituted. So it takes a great deal of research to find materials and then to identify them as being part of the original crust that formed on the moon.
Astrophysicists, those who study the sun and other stars to see what they've been doing in the universe throughout time, are also interested in the moon.
The moon has a very ancient surface, and so by studying the reactions that the moon as a target has had with the rays and with the particles that are given off from the sun and that are given off from other stars in the universe, we can see how the nature of these particles has changed with time, over 1 billion years at least, 1 billion years represented by the rocks that have been returned from the moon, cover that long a history. The moon is an analog, that is, we can use it to compare processes on Earth, and as we've learning more and more about other planets with processes with Mars, we can see that there are craters on Mars, and can use our sort of ground truth from the samples we've returned to the moon to try to figure out just exactly what sort of processes have been going on Mars.
The study of lunar material also helps us to better understand processes on meteorites and other planets.
And all these studies result in one product, essentially, and that's knowledge. And this knowledge starts out as detailed scientific reports and papers from the studies and of the samples themselves. And every year there is a lunar science conference in Houston that produces 3 large volumes with 1,000 pages each. And so there have been 9 of these conferences. And this information is distilled into textbooks on the moon, and it's further distilled into books that are used on earth science and planetary science as chapters and reach the people in college and in the high schools and even into grade schools. So the product of the effort on the lunar research is reaching, the knowledge reaches everyone eventually. A lot of the things that are discovered on the moon start out as theories or hypotheses. They're not proven yet by any means, and it takes a long time for a number of years for scientific people to get their models of what they think had gone on with the moon into order and where it can be distilled down and explained to, well, where people understand it well enough themselves to explain it to everyone else, is what the situation is.
Scientists question, what is the origin of the moon? Did it form at the same time as the Earth?
That indeed seems to be the case. Both planets are 4,600 million years old, 4.6 billion years old, expressed differently. Then the question comes, were they formed in the same part of the solar system? Were they the same distance out from the sun when they were formed? And the moon is a smaller body, and it has very much less iron than the Earth. And for that reason, many people, before we visited the moon and some afterwards, thought that the moon itself, because of this difference in its composition, was formed at a different place in the solar system from the Earth.
The core tubes, samples of lunar material taken from just below the moon's surface, represent up to 1 billion years of moon history.
Only half of those have been opened, and it's going to take us 3 or 4 more years to carefully open them, map, describe, and preserve the samples that are taken from those to get the maximum return in scientific knowledge from them. This is for the near future. We think or we know that the studies on samples will be going on hundreds of years from now. Undoubtedly, there'll be missions returned to the moon, and within decades or perhaps even shorter, 1 or 2 decades perhaps, and get more samples back. The Russians may bring back more samples, but those missions will not go back to the same localities. We'll be getting samples from new localities. So that the samples that we presently have, the nine landings that have been done to date, will be of interest for studies for on into the future for hundreds of years for those particular localities. And therefore, we're taking a great deal of effort to preserve those samples for future generations of researchers, so they'll be able to look at the samples. And it isn't just repeating what we've been doing on the samples, that scientific techniques, the techniques for looking at the samples, will have improved greatly. There will be breakthroughs in what can be done with materials to understand their origins. There'll be new theories to be checked out. And so we feel that our program really has to be conducted as though we were doing it for future generations of scientists and future generations of people who will learn and understand things from these samples.
NASA, the National Aeronautics and Space Administration, has presented a special report, Moon Rocks Today, a look at a legacy for tomorrow. Willard Scott speaking.